What's up, scientists? Today we're going to build rockets. We'll look at how rockets work and use chemical reactions to make our own. First, let's take a little bit to talk about rockets. Rockets are incredible machines designed to bring astronauts up to space, launch satellites, and ultimately explore space. Typically, rockets are thin and round vehicles with fins at the bottom. These fins make the rocket aerodynamic. Aerodynamic means fins will help the rocket fly well.
Use scissors to cut a piece of paper in half widthwise, like a hamburger. Second, wrap the paper around the film canister in tape so the paper covers the canister and forms a cylinder. The lid of the canister should be face down and out of the tube. Tape the paper so it stays in place. Third, cut and tape fins to your rocket. They can be squares or triangle. Which shape do you think will help the rocket fly better? Fourth, make a nose by cutting a circle and then a triangle out of that circle, like Pac-Man, and rolling it into a cone, then taping it into place. Then tape that cone on top of the open cylinder, the opposite end of the lid. Why do astronauts put cones on rockets? Fifth, decorate your rocket. Sixth, find an open space outside to launch your rocket. Seventh, turn your rocket upside down and fill the canister with 1/3 of the way with water. Eighth, break the anti-acid tablet in half. Ninth, drop the half of the tablet and snap the lid on tight very quickly. 10th, quickly stand the rocket lid down onto the floor and stand back. Be careful when launching your rocket and make sure it's not pointed at someone. 11th, once the rocket launches, you can repeat the launches by repeating the steps 9 through 10. Try to improve your rocket and make the launches higher.
Once you've launched the rocket a few times, get ready to learn how it works. First, let's talk about real rockets. Engines in rockets work by combusting fuel to form a gas. The gas fills up a chamber and shoots out the bottom of the rocket. This process of creating gas allows rockets to fly. Rockets that fly to space travel around 4.9 miles a second. That's faster than the speed of sound. When we put the tablet in the water, chemicals inside the tablet, citric acid and sodium bicarbonate, react to form a gas. The gas expands inside the container until the pressure of the gas explodes the cap off the canister. As I said earlier, this chemical reaction acts as the fuel that allows our rocket to fly. The only difference between our rocket and real ones is that ours only has one explosion. If we could keep generating gas, our rocket would keep going up. Phew, there's our chemistry for the day. Now let's talk about physics. When the cap explodes downward, the rocket is forced upwards. This is Newton's third law in action. You might have heard people say, for every action, there's an equal and opposite reaction. When the cap goes downward, the rocket goes up. Can you think of any other examples that use Newton's third law? Swimming, skateboarding, and even walking all involve Newton's third law. When you swim, your arm pushes the water against it, and the water, in turn, propels you forward. This may seem a little simple, but it's a very useful rule, so keep it in mind. Our rocket wasn't quite big enough for someone to fit inside, but I'm going to tell you about an astronaut anyway. This is Sally Ride. She was the youngest astronaut from the US to ever go to space. She went on the spaceship Challenger 2 times. That's over 2 full weeks in space. Afterwards, Sally Ride worked as a professor of physics at a few colleges. She really reached for the stars. If you come back tomorrow, we're going to do some more physics and engineering medieval style. That's right, we're making catapults.